Hi, I'm Vanaja Tirchelvam, and I'm here to demonstrate the application which were given by the module is called Programming for Data Analysis. So this is the Google Colab. Here we just importing the libraries and we are giving the permissions to access our drive to access the data, and I have selected the four places. I have added that the CSV files, and I am merging that file into one, and I named as a combined data set China Evolution, and I'm just reviewing the data, and then I am finding out what are the missing values are there here in the data, and then I just want to fill the data using the mode median method, and then once if I've filled the missing value and I have started to do the analysis. So this is my Google Colab notebook which represented the EDA analysis, and using this graph I have created the application using the Streamlit, and yes, it is working on a live URL. So let's move on to that application. Here we go. This is the application. So I have just added some background images, and this is the home page. I'm just giving the introduction, kind of that. So yeah, let's go on. So China pollution analysis dashboard. So I just give like unmasking the air we breathe. I'm just giving the importance of the air quality. So air pollution is a major environmental concern in China that is affecting the millions of people every day. The increasing concentration of pollutants like PM 2.5, NO2, and SO2 due to the urbanization and industrialization pose a serious health risk. By analyzing the data from selected regions, I just aim to explore the trends, access air quality, and aid best decision making while we consider the air quality index. So we have 12 or 10 data sets. So within that, I have chosen four stations for the analysis in the Beijing region. So for example, the first one is Guangguan. It's an urban area and the location is it is in the central Beijing. So why I chosen this? It's represent the dense urban traffic and pollution load. And the second one is Shuangyi. This is a suburban and it is located in the northeast suburb and of Beijing. And then why I chosen this, it shows the suburban growth and industrial influence. And in Japan, it's a semi-rural and northern fringe of Beijing. So why I chosen this is useful for the comparing if urban versus agriculture pollution sources. And the next one is Dinkley. It's a rural and historical area which contain near the mountains and North Beaching. So it's offering a cleaner environment for the baseline for the comparison. And this is the map I just put it for the visualization. So this is the China. I'm just putting the map to get to know the China. Yes, and this is my home page. So moving on to the next page. So this is called data overview. Here we are going to discuss about the air quality data overview. So these are the columns we are going to use for the analysis. So I'm just listing the data columns names in the data frame. Here we can see the see there, and we can download the data and we can search the data and we can expand the data as well here in the application itself. So this is the summary statics. So here I have just listed the count, mean, STD minimum, and 25% of the value, 50% and 75%, and the max value of that. So this is some statics I just visualize here in my application. And the next one is distribution of pollutants by station. So yeah, we can select the pollutants and we can visualize and we can see the graph. So in the first station, we can able to, like in PM 2.5, we can see the distributions like Gigling, Guangyuan, Nongguanyuan, and Xingyu, like that. So once we have changed to SO2, the graph will change. We can see that, right? And once you say in the CO, we can see the graph is changing. According to this, we can get the useful insight from these graphs. And usually the average, so we can list like the average PM 2.5 level across the all station is 77.79 concentration. And the highest record of PM 2.5 is 941.00, the concentration of Schwengi. Yes. So moving on to the next page, this is explanatory data analysis. So it consists of the data analysis. So we are here we can see like the air quality levels based on the PM 2.5, the count versus air quality index PM 2.5. So here we can categorize into the good, moderate, unhealthy for sensitive, unhealthy, and very unhealthy. So according to the count, we can categorize like these five sectors. Yes. And moving on to the next analysis, it's average pollutant concentration by season. So according to the season, like we have four season, autumn, spring, summer, and winter. According to the season versus the concentration, we can we can easily see and we can get a insights from this graph. So during the winter and autumn season, the O3 concentration is lower when compared to the other season like spring and summer, and the NO2 was lower in the summer season when compared to the other three seasons. It makes sense and we can able to easily get a good decision making according to the season. And moving on to the next graph, it's PM 2.5 monthly trends over years. So this is the graph according to the year, and PM 2.5 according to the month. We can check how the concentration of PM 2.5 is going. So when we check this one, actually it is 2014. It's go off after I think it's 150 in the month of 2, and in month of 4 it's 60. Here we can able to analyze according to the month-wise trend over the year and the worst station by average of PM 2.5. So according to the PM 2.5 concentration, the worst station is Nongjonguan. It's 84.26, right? And the minimum is 65.7009. It's Dingli. And moving on to the next one is pollutant during a peak versus off-peak hours. So we have selected the three pollutants like PM 2.5, NO2, and CO, and off-peak and peak. But in this graph, we have seen that only the few minor differences, not a major differences. We can easily get to know about. So the pollutants is according to the peak of the powers, it's not give a major difference. And the pollution by station, and that was the station versus concentration. So we have chosen the three pollutants like PM 2.5, NO2, and O3. So here it is. And the 30-day rolling average of PM 2.5. So here we can easily vary it like 30-day mean and PM 2.5, how the distribution is going up and down. and then distribution by season. We have four seasons as I mentioned previously, and according to the number, we can clearly see that how the season is getting involved due, in the air quality index, right? And moving on to this next one is PM 2.5 versus temperature. So according to the temperature, if the in the like from zero to 20, we can see from minus 10 to 20, we can see there are a lot of concentration. The high PM 2.5 was high. Yeah, so the temperature is taking up, it's impacting the air quality index, right? Yes. And then moving on to the wind speed, the same as wind speed is from 0 to 4. We have seen that there are a lot of concentration is there of PM 2.5, and then PM 2.5 versus NO2 by station. So we have differentiating like NO2 and PM 2.5, the same one like Swingi, Nongyang, Gwangi, and Dingley. So according to the color, we have differentiated. We can easily check that the majority of this is was jingling, sorry, dingling. We can check, we can see here the red one is the majority one, right? Yes. So this is my EDA analysis page. And moving on to the next page is model training and evaluation. It's loading. So when I try to do the model training and evaluation, I have selected the two models like decision tree and random forest. Yes. So according to the accuracy comparison, so in decision tree I got 0.81 percentage, and the in random forest I got 0.88. So the accuracy level when compared to two model, the random forest is high. Here we can clearly see. And the confusion matrix, we can check like in decision tree, the good is actually 12,154, and here in the random forest is 12,610, and the very unhealthy is to 2011 in the random forest, and in the decision tree it's 1877. This is the predicted one, and the actual one we can clearly see, and we can get a valuable insight from this, right? Yes. Moving on to the next page is summary. I just did some like a air quality index calculator. It's like a prediction. Uh, we can we can adjust the values of the pollutants variables like that. We can easily like, it will predict whether the air quality index is moderate or good or bad or poor like that. So I just want to show that one also here. Yes. So we have some like our PM10, SO2, NO2, CO2, O3 like that, temperature, wind speed like that. According to these values, we can easily predict the air quality index, whether it is moderate or poor or good or bad like that. So this is what I have developed for the air pollution application, China Air Pollution Index analysis application. And thank you very much for giving this opportunity. I would really like to thank my lecturer to gain this self-study experience to create this application using the Streamlit. Yeah, thank you.